In today's lesson, we're going to look at subtracting mixed numbers, and we're going to see how it's a little bit different from when we simply added mixed numbers, because we're going to be using borrowing in order to help us subtract. So before we go ahead and practice the whole process of subtracting, we're going to look at what it means to borrow when we're dealing with mixed numbers. The first step we're going to do is we're going to take away 1 from the whole number. So if we start with 4 3/7, I'm going to change that 4, I'm going to take 1 out of it, I'm going to make it 3. Now I'm not going to get rid of that whole number. Remember, I want to have my borrowed mixed number be of the same value, so I can't just get rid of that 1, but I'm going to add it to the fraction that I have here. How I'm going to do that is I'm going to make the denominator of the whole that I borrowed the same as the denominator of the fraction that I'm adding to. So I'm going to make it a 7, since 3/7 has a 7. Since it's a whole that I borrowed, I took a whole 1 away. The only way to make a fraction equal to 1 that has 7 on the bottom would be to have the exact same number, a 7 on the top. Any fraction that is one number over the same number on the bottom, well, 7 just goes into 7 one time, and there's no remainder if I were to go about changing that into or to try to change it into a mixed number. So 1 whole can be represented as 7/7. So that 1 whole I took from the 4 here, I'm simply moving over and adding to that fraction. So then I would have 10/7. So my new fraction would be 3 10/7. Notice, like it says with the asterisk, remember that the value should not change. So 4 3/7 equals 3 10/7. It just looks a little bit different. And again, if we go back and kind of check a review, if I looked at 10/7 and I wrote that as a mixed number, 7 goes into 10 one time, and 10 minus 7 would be 3. So I would have 1 3/7. So 3 plus 1 3/7 would be 4 3/7, which is exactly what I started with. Let's take a look at the next one. If we have 8 1/3, again, I'm going to start by taking away 1 from my whole, so I'm going to make that a 7. I'm going to add that whole over here. This time, since my denominator is currently a 3, I'm going to go ahead and make this denominator 3. In order to make this 1 whole, the only number I can put there is a 3. If I put 2/3, that would be less than a whole. If I put 4/3, it's going to be more than a whole. So I have to add 3/3 to it, and I'm going to get 7 4/3. Again, if I want to go back and check, I would have 7 plus, if I change 4/3 into a mixed number, I'm going to have 3 goes into 4 1 whole time, with a remainder of 1 1/3. So notice 7 plus 1/3 would be 8 1/3, which is exactly what I started with. So 7 4/3 is going to be my borrowed mixed number. If you're getting the hang of this, I encourage you to turn off the video and give this example a try, and then restart the video to go back and check your work. In this one, again, I'm going to start by borrowing a whole here. Since I only had 1 to begin with, I can either write 0 as my whole number, or I can just leave it blank, put nothing there. I'm using my whole number here. I'm representing it instead of 1 whole as a fraction. This time I'm going to choose 11 as my denominator, since I had 11 to start with as my denominator. And I'm going to have to put 11 there to make it a whole. Not 10 again. If I had 10 11ths, it'd be less than a whole, be too little. 12 11ths would be a little too much. If I combine, then I'm going to have 21 11ths. Notice this is the same process I would get if I took 1 10 11ths and I turned that into a mixed number. So I did 1 times 11 is 11, plus 10 would be 21 11ths. Means the same thing. So 21 11ths is going to be my answer. Now that I know how to borrow, my procedure for subtracting is going to be almost the same as it was when I was adding fractions. So I have a lot of steps up there, but a lot of them should be familiar to you in kind of a review. So I'm going to start off the same exact way I started when I added mixed numbers, and I'm going to look for or find common denominators. So I'm going to take the fractions 1/3 and 1/2, and I notice that they both are going to go evenly into 6. So I'm going to place 6 as my denominator. From 1/3 to get to 6, I multiplied the denominator by 2. So I'm going to have to do the same thing to the top, multiply 1 by 2. So I'm going to have 2 and 2/6. Now, for 1/2, I multiplied the denominator by 3, so I'm going to have to do the same thing to the numerator, and I have a new problem set up, 2 and 2/6 minus 1 and 3/6. The big important part to remember here is step 2. The difference between adding and subtracting mixed numbers is that I have to check and compare my two fractions. If the first fraction, so 2/6, is bigger than the second fraction, 3/6, I'm going to move on to step 3. If the first fraction is smaller than the second fraction, I'm going to borrow from the whole number before I move on. What I notice is my first fraction is 2/6, my second fraction is 3/6. 2 is smaller than 3, so I'm going to have to borrow. Important that I make common denominators before comparing, because without common denominators I can't tell the size or tell which one is bigger. So now I'm going to have to go ahead and borrow. So I'm going to change this 2 here. I'm going to take away 1 from it and make this a 1. Then here I'm going to have to add 6 over 6, since my denominator was 6, to that fraction. So I'm going to have 1 and 8/6. And then I'm going to subtract 1 and 3/6 from it. Now, step 3 says to subtract the whole numbers to create the whole number for my answer. Well, I have 1 minus 1, so my whole number is going to be 0. Or I could leave it blank, but I'll show the 0 here for our own visual aid. Then I'm going to subtract the two numerators to create the numerator. Again, very similar to what I did when I was adding mixed numbers. So 8 minus 3 is 5. Then I'm going to subtract I'm going to use the common denominator as the denominator for my answer, just like I did before. And simplify if necessary. Well, when I look at 5/6, there's nothing I can simplify, so my answer is 0 and 5/6, or just the fraction 5/6. Again, what I have to be aware of, it's really tempting to subtract those whole numbers and get 1, and then to subtract 3 and 2 and just think, well, 3 minus 2 is 1, even though that's not the correct order, and get 1 and 1/6. But if I look at this and I round my answer, because this is going to be incorrect, what I should notice is, if I round 2 and 1/3, that's really close to 2. So I'm going to have 2 minus 1 1/2. We'll round to either 1 or 2. I mean, following normal estimating rules, we would go up to 2, so it's about 0. We don't have a whole number answer. Our answer is going to be a fraction, or it's going to be pretty small. So 5/6 looks good there. Let's go through one more example together before you try some on your own. I'm going to start out by finding common denominators. What I notice immediately when I solve this problem is that I only have one fraction present. I do not have two fractions there. Again, it's really tempting to just do 6 minus 2 is 4 and then take that fraction, but that's not going to help me get the right answer. What I'm going to have to do, again, if I estimate before I start, I would keep 6 as 6, 2 and 3/4. 3/4 is pretty close to the number 3. So 6 minus 3 is 3, so our answer should be about 3. What I really have, if I made this fraction with a denominator of 4, is I really have 0/4. So I'm doing 6 and 0/4 minus 2 and 3/4. Well, I can't take away 3/4 from 0/4. I don't have any here to take away from. So what I'm going to do is I'm going to go ahead and borrow. I'm going to, again, make this 6 into a 5 by taking away that 1. And I'm going to add 4/4 to 0/4. I'm just going to create the fraction there. I'm going to have 5 and 4/4 minus 2 and 3/4. Then it's just a matter of going through the steps that I remember from yesterday, starting with the whole number. So doing 5 minus 2 is 3. 4 minus 3 is going to be 1, so that's my new numerator. My denominator is going to stay the same as that common denominator of 4. So my answer is going to be 3 and 1/4, which again is really close to 3 what I get when I estimate. At this point, watch or read through any of the steps that you need to go through and be clear about, and give each of the rest of the problems on the worksheet a try.